Hi, welcome to the class. Today we are going to do an experiment where we are going to find the focal length of a convex lens, but this time the method which we are going to use to find the focal length of a convex lens is by using lens formula. So this time we are going to use the lens formula and then we are going to calculate the focal length of the convex lens. Before this we have done the same, that is we have calculated the focal length of a convex lens, but that time we have used distant object method. So what all are the requirement for this practical? So we need a candle here, we need a stand, that is the lens holder. Then we have a screen there and a scale, and along with a scale we need marker. So this much we need in order to do this practical. So how we are going to do this practical? So very first you have to fix this candle like this. So we have fixed the candle. Now using distant object method, you calculate the rough focal length of this lens, which we have done. Now, the rough focal length of this lens is 15 centimeter approximately. Now, what we are going to do, the very first distance which you are going to mark on the table is 25 centimeter. Why 25 centimeter? It has to be greater than, it has to be, so this mark is 25 centimeter. It has to be greater than, it has to be greater than the focal length of the lens. So how did we know the focal length of the lens? So by focal length of the lens I mean the rough focal length of the lens, which is 15 centimeter, and that is calculated by distant object method. So 15 centimeter is the rough focal length of the convex lens. So we have to keep the very first distance more than the focal length of the lens. So it can be 20, it can be 25. I have taken 25. Now after interval of 5 centimeter, you have to increase the distance. So this is 25, the other one is 30, then 35, then 40, 45 and 50. So I'm going to take 5 readings only. So these are the distances at an interval of 5 centimeter each. So the very first place where the lens is kept is 25 centimeter. So the the object distance, object is the candle, so object distance from the lens is 25 centimeter. So we have taken this 25 centimeter, which is the very first object distance. So here I have written the data. So you can check out the data here. U is the object distance, V is the image distance, F is the focal length, and to calculate the focal length we are using the formula UV upon U plus V. Now why you are using this plus, although in lens formula we have this negative 1 upon V minus 1 upon U is equals to 1 upon F, because here we are not much worried about the sign convention. So we are not considering the sign convention, that is why I have written this plus here. So all the object distances I have written, as you can see, 25 centimeter is my first object distance. Then I'll increase it to 30 centimeter, then 35, then 40, then 45. Alright, so let's begin the experiment. In order to find V, and after finding V, we can easily calculate F. Okay, so here what I'm going to do, I'm going to move this screen back in the forward and the backward direction, and as you can see we are getting an image of this candle, which is inverted image. So the point at which I get the sharpest image, there I'll stop. So this is the sharpest image. So as you can see, it is an inverted image. So inverted image of this. Now the next what we are going to do is to measure the length of this screen from the lens. So from the center of this stand to the center of the screen, and it is coming approximately 38.5 centimeter. So in this case, when the U was 25 centimeter, V is 38.5 centimeter. So this is 38.5 centimeter. Then the very first value of F will be 38.5 into 25 upon 38.5 plus 25. So this if you calculate this, it is going to come approximately, actually we have calculated, taken the values earlier. So it is coming 15.15. So the very first reading has come 15.15. Now the object distance, we have to make this object distance as 30 centimeter. So now it is 30 centimeter. Now my question to you before proceeding this is, when you increase the object distance, what is going to happen to the image distance? The very first reading of image distance is 38.5 centimeter. My question to you is, 38.5 centimeter image distance is for the object distance of 25 centimeter. When you increase this object distance to 30 centimeter, what will be the image distance? Will it be more than 38.5 centimeter, equal to 38.5 centimeter, or less than 38.5 centimeter? So what you have to do, take a pause and think about this, and then you can start the video again. This is all related to the image formations which we have done in your theory part. So image formation you have to keep in mind. So whenever you keep an object at a distance which is greater than the focal length of this lens, then what happens to the image distance if you increase the object distance? So this is what you have to think of. So let's begin and let's find out. So here you can see it's a blur image, and it's a blur image again. So yeah, so this is a very sharp image. So I'm going to stop here. So you can see it is very sharp image, and again it is an inverted image. So if I measure the distance, obviously you'll get an idea, and it is around 30.5. So the image distance, when the object distance is increasing, the image distance has reduced, which was quite much expected. So for 30 centimeter it is 30.5, I think. So anyway, if you calculate this, it is going to come approximately, let me calculate this value for you. So it's 30 into 30.5 upon 30 plus 30.5. So it's coming 15.12. All right. Now let's increase the object distance again. Take it to 35 centimeter. Repeat the same thing. Now will it be more than 30.5 or less than 30.5 or equal to 30? So you can see here we have formed a very sharp image. If I measure the distance, yes, it is coming approximately 27. So as you can see, as you increase the object distance, image distance is decreasing. Let me check. Okay, again I have to calculate it. So it is 35 into 27 upon 35 plus 27. So I'll calculate this again for you. 35 plus 27. So it is coming 15.24. So let me take one more reading, that will be my last reading. If I shift my, in this case I'm not shifting my object, I'm shifting my lens because it is convenient to do that. Okay, because if I move the candle, then it is melting and then heated up, so it can be a problem. So best is to move your object. Now the image distance has become 40 centimeter. So will it be more than 20 7 or will it be less than 27? Find it out. So in this case we are getting a very small image, and that is a point size kind of image. Not very sharp, but it's okay. So this is the image. So it's like a point kind of image. So yeah, we are getting 25.5 in this case, which is again less than 27. So it's a very point size image. As you can see, it's just a point on the screen. So it is 25. So 40 into 25 upon 40 plus 25. So 25 4, it will be 1000 divided by 65. You have to calculate this. 65, 1000 divided by 65. And it is coming 15.38. So guys, after taking these 4 readings, 1, 2, 3, 4, one more also you can take, and then you have to calculate the mean. So your result will be, that is the focal length of this convex lens, will be the mean of all these readings. So mean means 15.12 plus 15.24 plus 15.38 and then divided by 4. So this will be a result which is obviously within the range of 15 something. So that much centimeter, 15 point something, that much centimeter will be the focal length of this lens. Now I would like to mention one important thing through this chart. The image formation which we have already done, and from this chart it is quite evident that when you increase the distance of the object from the lens, the image distance decreases, it shrinks. So when the object is kept at focus, image is formed at infinity, very far away. When this object is taken to infinity, image starts moving towards the focus, and when the object is at infinity, image is formed at focus. So you can see as we move the object away from the lens, the image starts coming closer towards the lens, and this is quite evident from your image formation by convex lens also, and from this experiment also. So there were quite a few things which you can learn and also relate with the theory taught in the class. Thank you.